Hi everyone. We're going to talk about piecewise functions again today. This is something we already saw in Module 2, but instead of just introducing you to a piecewise function, telling you how to use them, today we're going to focus on how to graph them. But let's start off with a quick review of what you guys already know from Module 2. The first time we talked about piecewise functions, I said a piecewise function is a function that has more than one equation. So it might look like this. Here's an example where we have f of x, our function. It's equal to, and then you see that little curly bracket there. That's the key that tells you it's a piecewise function. It groups together more than one equation. So basically what this equation is saying is sometimes f of x equals negative 3x minus 1, but sometimes it doesn't. Sometimes f of x equals 2x plus 7. So you have two different equations here. A piecewise function can have more than two. You can have 3 or 5 or 10 equations, but this one has 2. Now the second part over on the right there, that's called the domain, and that tells you when to use each equation. And I said a good way to think about it, just think of that comma like it's the word if. So that top row of our piecewise function, what it really says is f of x equals negative 3x minus 1 if x is less than negative 2. So if x is any number less than negative 2, it's negative 3 or negative 10 or negative 1 million, then you use that top equation. Now the second line says f of x equals 2x plus 7 if x is greater than or equal to negative 2. So any number negative 2 or bigger, negative 2, negative 1, 0, 10, 100, a million, any number greater than or equal to negative 2, use the bottom equation. All right, so that's our review. That's what we did the first time through. What we're going to do today is talk about how to graph a piecewise function. Now, the number one rule for graphing a piecewise function is you have to graph each piece separately. If there's 2 equations, you're going to do 2 graphs. If there's 3 equations, you're going to do 3. If there's 10 equations, which would be a hard one, I wouldn't give you one like that, but if there was a piecewise function with 10 equations, you would have to do 10 different graphs. There's no shortcuts, you got to do each piece separately. Now what you want to do is start the question by splitting the graph into pieces using the domain. So for example, that one I showed you before, it was like one of them is x is less than negative 2 and the other one is x is greater than negative 2. So negative 2 is kind of where it splits. You're going to have one graph on one side and one on the other. You want to start by identifying those points and marking them on your graph. Now, when you go to draw each piece, it's called a piecewise function because you're actually only using one piece of each graph. Now, it's hard to draw a piece of a graph, so sometimes it's easier to just draw the whole thing and then erase the part you don't need. The last little thing here, and this is kind of a weird one, I'm going to give you the rules for it, and then when we do the example, I'll talk about why we do this. But basically, we have our little boundary, like at negative 2. We have a graph that hits that boundary and just stops. Right where it stops, you're either going to end with an open circle, a little circle, or what we call a closed circle, which is a filled-in circle or a dot, a point. So here are the rules. If the domain ends with less than or greater than, you do the open circle. You end with a circle there. Now the closed circle, or the dot, the point, is for when the domain has the or equal to on it, less than or equal to or greater than or equal to. And like I said, we'll do an example right now, and when we do, I'll explain what those open and closed circles mean and why we do it. So let's graph for our example today. Let's graph the same function we just did. F of x equals negative 3x minus 1 for x is less than negative 2, and 2x plus 7 for x is greater than or equal to negative 2. And I'll go ahead, I'll draw myself a blank graph here so we have something to work with. And we'll mark some points on it. Okay, that'll work. All right, so the first thing I'm going to do, remember, before I worry about graphing functions, I look over here at the domain, and I said before, this is my key number. -2 is where it's going to switch from one point to another. And we're talking about x's. So you're talking about when x is -2. So when x is less than -2, I do one graph, and when x is greater than -2, I do the other. So the first thing I do is I find -2 on the x-axis, which would be 2 spots to the left. And I'm going to put in a vertical line right there. Now see, that red line that I just drew, that's where x equals 2. That means everything to the left of that line is where x is less than -2. Sorry, I think I said 2, I meant -2. And everything to the right of that red line is where x is greater than -2. And the red line itself is where x equals -2. So I've split my graph in half. I want to have one graph on the left of that line, one graph on the right of that line, and let's do that next. So let's do them one at a time. Start with the first one. F of x equals -3x minus 1. Forget about the 2x plus 7 for now. We'll do that in a second. And I'm just going to graph that. This is just graphing a line. Just like we talked about, it's in slope-intercept form, which means the -1 is the y-intercept. So I'm going to count down one spot and put a point. There's my y-intercept. Now the slope is this number right here, -3. If you want to make it a fraction so we can do rise over run, just put it over 1. So the slope, or the rise over run, is -3 over 1. So what I might do is go, let's do, since it's negative, let's count down 1, 2, 3, and then one spot to the right, and that's our line. So what I'm going to do, I'm going to draw the whole thing first. I'm going to draw the line like this. It's a little bit, it's not perfect. It's hard for me to draw on my little writing tablet sometimes, but you get the idea of that light blue line there. Now, before we finish, we're going to end up erasing half of that. So I go back up and I say, okay, remember we're doing the top equation. So I really only want that equation where x is less than -2. X is less than -2 is this side of the line. So I want to erase everything on the other side of the line. I want to erase all of this. Oops, I didn't want to erase that. I'll put that back. I want to erase all of that on the right side of the line. So see how what I did is I actually graphed this whole line. F of x equals -3x minus 1. Then I went to the domain here and I just kept the part I needed. I said I only want that line where x is less than -2. That was on the left side of the red line, so I kept that. Now the last thing I do to finish that, remember right where it hits that dotted red line, I need to decide whether to put a circle or a dot. And if I look at the domain, it's circled in light blue there. It says x is less than -2. Now remember, if you don't have the or equal to, you end with an open circle there. All right, we are exactly halfway done with the question, because now I have to do the exact same work, but with the 2x plus 7. So now let's do the second equation. F of x equals 2x plus 7. And I'm going to graph that line. Just do the whole thing for now, just like we did before. The y-intercept this time is +7, so I'm going to count up. 1, 2, 3, 4, 5, 6, 7. Put a point right here. The slope is +2, so I think I'm going to have to extend this into the problem here. I kind of ran out of space, but that's okay. We'll work our way up here. The slope is +2, so to make it a fraction, we put it over 1, which means for rise over run, it's going to be up 2 and over 1. So from that point, I count up 1, 2, over 1. I would have a point right there. It's kind of on top of my n, basically. But what I'm going to do now is I'm going to have that line right there. But now remember, I only want to keep half of the line. So I look back at the domain. This one is x is greater than or equal to -2. So I'm not really worried about the or equal to yet. But this one I want over here on the right, where x is greater than -2. So I'm going to erase this part over here on the left, keep the side on the right, and then my last thing is I look back here and I say this one for the domain I did have the or equal to. So I want to put the closed circle or the point right there. Now this is my final answer to the graph. It's a piecewise function, it has two pieces. Each one was a line. Each one I was doing slope-intercept form, y equals mx plus b. But I only kept half of each one. And one important thing, they should never overlap. Like right here where x equals -2, I should only have one graph over here on the left side of the line and one graph over here on the right. So if you're ever doing a piecewise function, let's say you do this, and you end up with a graph that looks like this. You have one piece up here going this way and another piece going here down that way. You made a mistake. That cannot possibly be the answer because that's not a function. If you remember, we talked about the vertical line test. There's a vertical line right here that crosses the function twice. So you can't ever have two on top of each other like that. When you have a piecewise function, you always have one on the left and one on the right, like this. But if you ever have two pieces on top of each other, you've made a mistake somewhere. Go back and check your work. They can't overlap like that. Now the last thing I want to talk about before we finish is that whole circle versus dot thing. The idea is, remember, when you're graphing a function, you're actually plotting points. Now on that dotted red line, if I had 2 points like this, let's say I put closed circles for both of those, then it can't be right again because it fails the vertical line test, just like we talked about just a minute ago. On that dotted red line, there are 2 points. That can't happen for a function. So what we want to do instead is decide which one is the point. And the point always goes where it's equal to the number. So when x equals -2, look at the one circled in purple on the top right of the screen. Because that has the or equal to, when x equals 2, we use the graph 2x plus 7. That's the purple one. That's why that gets the point. The open circle is like a marker that says, yeah, the graph is kind of going there, but there's no point there. The point is at the other place. So the filled in dot, the closed circle, represents the point on the graph. The open circle represents an empty spot where the other graph is ending right there. It's a little bit confusing, but just remember, you can only have one point on that line. If you put 2 filled in circles, it's not a function anymore, and that doesn't work.